Good morning, students. In my last lecture, I have completed up till question number 6 of the application of trigonometry. Now, directly I'm going to question number 7. It says that from a point on the ground, the angle of elevation at the top and the bottom of a transmission tower fixed at the top of a 20-meter high building are 45 and 60 degrees respectively. Find the height of the tower. Find the height of the tower. So this is question number 7, and this is can be drawn like this. That is the shape and like this. There's some at a distance these, and let's suppose it's a transmitter tower, so it can look like this, can look like this. So this, and if you join this 2 point, it looks like this. Now what the question says that it says that the height of the building is given to be 20 meters, angle 45 degree and 60 degree respectively to bottom and top. So this is 45 degree and this is 60 degree. This is my tower and the height of the building is given to be 20 meters. Now if you draw this in a triangular form, so it will look like this. Something like this. Something like this. So look like this. This figure ultimately will look like this, and this is angle to be 45 degree. It is in triangular form. I have drawn this both in triangular form and this is h equal to 20 meters the height of the building. Now this we need to find, this distance you need to find, and let's just suppose that this is A, B, this is C, and this is D, and you already know that this is the ground, so this will be the perpendicular. This is the ground. This is basically the building. EB is a tower, and D is a point on the ground. So we need to find the value of AB. Now, now consider that you can see that in triangle BCD, angle C is 90 degree, BC is 20 meters. Now, and angle D equal to 45 degree. So if you want to calculate, if you want to know this DC and this BC is given, then only one thing, that is tan theta, this is perpendicular by base, and tan theta equal to, but here this theta is nothing but 45 degrees, tan 45 degree equal to 1 is what? BC by DC, BC by DC, and BC is given to be 20 meters by DC, which is equal to 1, which implies that DC equal to 20 meters. So from here you could calculate, you have calculated this is 20 meters. Now in triangle ACD, triangle ACD, angle C 90 degree, and AB you don't know, and this angle D is 44, angle D is 60 degree, and DC you have calculated as 20 meters. So for AC by AD, for AC by DC is nothing but tan of 60 degree is equal to, tan 60 is 1 by, sorry, this is root 3. Now which implies that this AC you don't know, this AC by DC you have calculated as 20 root 3, which implies that AC nothing but 20 root 3 meters. So AC 20 root 3 meters. But you also know that this AC nothing but AB plus BC. So this AB you don't know, you need to calculate, that is height of the tower, and BC you know that this is 20 meters, and AC is AC. If you write the value of AC here, this is 20 root 3. So which implies that the value of AB from here, this AB is from here, this is 20 root 3 minus 20, which is nothing but 20 into root 3 minus 1 meters. Or you can even write 20 root 3 minus 1 meters, which is the answer. This is the answer. The next is question number 8. Next is question number 8. What is question number 8 says that it says that a statue of 1.6 meter tall stands on the top of a pedestrian. So top of a pedestrian, this pedestrian must be having some height. From the point on the ground, the angle of elevation at the top of the statue is 60 degree, and from the same point, the angle of elevation to the top of the pedestrian is 45 degree. Find the height of the pedestrian. So it is like something like this. The figure looks something like this. This is your pedestrian. Pedestrian, and there's a point P on the ground. So this point P is on the ground. It is given that there is a statue here. So let's suppose this is my statue. This is my statue. The pedestrian, and from this point P, this of a pedestrian is this. So according to question, it is given that the height of the uh, this 20 meter top 20 meter high building. This is 1.6 meter tall statue. This height is going to be 1.6 meters, and the angle of elevations are this is 60 degree and 45 degree. So this is my 60 degree. This is my 45 degree. This is ground. It's pointed at ground, and this height of the height of the pedestrian. And this you need to find. You don't need to find this. So if you draw the simple diagram of this, it's nothing but a simple triangle. So this is given to be 45 degree. This is to be 60 degree. Remember that you need to use both of these angles in the question, which is given in the question, and it is given that this much height is 1.6 meters. This is 90 degree. Let us suppose this is point P. This is Q, this is R, this is S. And this RQ you need to find. Now you can see that we are in triangle RQ. No, you don't know this RQP. You cannot find. So let me rewrite it as this is SRS in triangle SQP. SQP. What you know that this angle P is here 60 degree. Angle Q is the 90 degree, and SR is 60 degree. Sorry, 1.6 meters. So the common in these two triangles SQP, that is in triangle SQP and triangle RQP, the one thing which is common is PQ side. Is common to both this and this. So from here in this, if I am at here, so I need to calculate tan of, this is tan of 60 degree, which is nothing but SR, or you can directly, or you can first write is SQ by PQ. PQ don't know, and but this value tan of 60 degree nothing but root of 3, which implies that PQ equal to SQ by root 3. This is one equation. Now in triangle, next is that in triangle RQP, you know that this angle P is given to be 45 degree for this triangle, and P is 45 degree, angle Q is 90 degree, and this much is given to you. Now tan of 45 degree, tan of 45 degree, this is RQ by PQ is given. Now RQ is not given to, so you can take RQ, and from here this PQ is given to you, so you can substitute the value PQ here, that is, which implies that this is nothing but by PQ, and PQ value substitute this is RQ by SQ by root 3, which is nothing but root 3 RQ by SQ, and tan 45 you already know this is 1. This is value of tan 45 degree is 1. Now next what you need to do is, so this SQ is equal to root 3 RQ. Now you know that what is SQ. Figure you can say SQ is SR plus RQ. SR plus RQ is SQ equal to root 3 RQ. Now you are given that SR is 1.6 meters. So this is 1.6 plus RQ equal to root 3 RQ, which implies that root 3 minus 1 RQ equal to 1.6 meters, implies that RQ is nothing but 1.6 by root 3 minus 1. Or alternatively, this can be your answer, root 3 minus 1. But if you need to multiply and divide, I can write it as root 3 plus 1. Just conjugate this root 3 plus 1, and this is already given root 3 minus 1. So if you solve the denominator quotient, this is 1.6 into root 3 plus 1. This will become root 3 whole square, which is 3 minus 1 goes is 1 only. So from here it will give you that is RQ equal to 6 by 2 into root 3 plus 1, which is nothing but RQ is 0.8 to it is 16, and it is root 3 plus 1 meters. This is the height of the pedestrian. The ninth, the angle of elevation to top of the building from the foot of the tower. See, angle of elevation to top of the building from the foot of a tower is 30 meter, and the angle of elevation to top of the tower from the foot of the building is 60 degree. If the tower is 50-meter high, find the height of the building. Okay, so this is question number 9. I think this is one 9. This is ninth question. Ninth question. There are two buildings. There are two buildings. So one you can take it as this building. This is given that this is angle of elevation is 30 degree. Top of a building or foot of a tower is 30 degree, and the angle of, so this is, you can say this is building 1, and next you can say that this is your building 2. What's great? Tower and building. So I'm joining this. And according to the question, it is said that this is building from foot of tower. Tower is and from the window 60 degree. So this is 30 degree and this 60 degree. So this is 30 degree. This is my building. This tower. You will answer how you can separate a tower height unit and building. So it is given that the top of the building, angle of elevation from top of the building foot of tower 30 degree. Okay, this is 30 degree, and then next is given that from the tower elevation of top of the tower from the foot of building 60 degree. Since angle is greater in second case, that is from the top of the tower, the top of tower from the foot of the building is greater, which implies that it is this, and this is angle is greater, so the height of tower is be greater. So now if I join this and this, it is given that this is 60 degree, and if I join this and this, given to be 30 degree, and only one height, that is height of the building. No, the if the tower height is 50 meters, so only this height is given to me as 50 meters. It's saying that we need to find this height. What? Now I'm drawing a simple figure. This is 10. No, sorry, 9. This is my ninth question. So I'm trying, if I draw a simple figure, triangle figure only. This will look like this. So this angle is given to be 60 degree. This is my 30 degree. This is building. I need to calculate this height. I don't know. This height is given to be 50 meter, which is the tower. So let me first suppose I am taking this to be A, this to be B, to be C, this to be D. And you very well know that this angle is 90 degree. Angle B and angle C is 90 degree. So now in triangle, see, I know this is 50 meters, so I will start with this triangle. So in triangle DCB, angle C is 90 degree and angle B is 60 degree, and DC is given to be 50 meters. So the common thing in these two triangles ABC and DCB is BC. This is common. So this is perpendicular by base with respect to tan 60 degree angle. So this is tan 60 degree can be written as DC by BC. DC is going to be 50 meters and BC you don't know. But this tan of 60 degree, you know that this is nothing but 3, which implies that BC is nothing but 50 by 3 meters. 50 by 3 meters. Now BC is given. Now coming to in triangle ABC, BC you have already calculated, and this 50 by 3 meters. Angle B is 90 degree, angle C is 30 degree. So AB by BC, AB and BC you need to, so this is with respect to 30 degree, this AB is a perpendicular, BC is a base, so tan of 30 degree, nothing but AB by BC, and you know that is tan 30 is nothing but 1 by root 3, which implies that AB by BC you already know that BC is nothing but 50 by equal to 1 by root 3, which implies that AB equals 50 by root 3 into 1 by root 3. Implies that this AB is nothing but 50 by 3 meters. 50 by 3 meters. So the height of the building is 50 by 3, sorry, 50 by 3 meters. 50 by 3 meters, which is the answer. Which is my answer. Next is question number 10. Question number 10. What it says that two poles of equal heights are standing opposite each other on either side of the road, which is 80 meter wide. So road width is 80 meter wide. From a point between them on the road, any point is between them, the angle of elevation top of the poles are 16, 30 degrees respectively. Find the height of the pole and the distance of the point from the two poles. This is also a simple question. This can be drawn simply. There is an equal length pole poles, and and there is a road in between. This is, you can say, this is suppose this is my road. Now the width of the road, that is this length, or this in case this case the width is 80 meters, and there is a certain point P. This is suppose this is my point P, and from point P the angle of elevations are 60 and 30 degrees respectively. So this point is nearer to this, which means the angle will be greater. So this is my sorry sorry so this is my angle 60 degree, and this is my angle 30 degree. Let us suppose this is A B and this is C B. Now it is given, what is given the question, that this A B equal to DC. Why? Because it is the equal pool, equal height pools. Now this equal height pools, so uh, you can take any triangle. So I am taking first in triangle A B P. This angle is 90 degree by default. So angle B is 90 degree, angle P is 60 degree. So now you need to get a tan of 60 degree, nothing but AB by BP. AB by BP. What you need to calculate is, okay, find the height of the poles and the distance of the point. Okay. AB by BP. So this AB by BP, and root 3 tan of 60 degrees, you know that this is nothing but this is root 3. It implies that AB is nothing but BP root 3. Taking this to be my first. Now in triangle DCE, not the combination of this is a triangle. So angle C is 90 degree, angle P is 30 degree. So what this is tan of 30 degree, or tan of 30 degree, it is nothing but DC by BC. And you know that this tan 60 degree is nothing but 1 by root 3, which implies that EC equal to DC by sorry implies that DC equals PC DC equals PC by root 3. This is my second equation. Now from 1 and 2 equation, both are AB equal to DC, because these are two equal height poles, which implies that BP root 3 equal to PC by root 3, which is, or you can say that is PC is nothing but 3 times BP. Three times of BP. Now you know that BC equals BP plus BC. You can see from there only that BP plus BC is 80. BP plus BC is BC, which is 80 meters, which implies that this BP, and from here you can substitute develop PC. PC is 3 BP equal to 80 meters, which implies that 3 plus 1 is 4. 4 BP equal to 80 meters, which implies that BP equal to 80 by 4, that's about 20 meters. 20 meters. So BP is 20 meters. Now BP is 20 meters. So PC, from here you can calculate PC. So what is PC? This is my equation 3. If I write it to my equation 3. So from equation 3, what you can write is that So this PC is nothing but 3 times BP, 3 times BP, which is nothing but 3 into 20, which is nothing but 60 meters. 60 meters. What is the height? So height is, you can, any one formula you can use, that is DC equal to PC by 3. So equals PC, what is PC is given to be 60 by root 3, nothing but 60 root 3 by 3, which is multiplying dividing by root 3, which is nothing but 20 root 3 meters. So the what all things we need to find is that, find the height of the pools. So the height of the pools is 20 root 3 meters, and the distance from the point from the pools. So distance of point from poles is 20 meters from one side and pole, and 60 meters from other side of the pole. Which is the answer. Which is the answer. Now next question. Next question is question number 11. State that question number 11 says that a TV tower stand, this is diagram is already given. TV tower stand faltering on the bank of a canal. Bank of a canal. From a point on the other bank, from a point on the other bank directly opposite to the tower, the angle of elevation of top of the tower is 60 degree. From another point 20 meters away from the point of the line of joining this point on the foot of the tower, the angle of elevation of the top of the tower is 30 degree. Find the height of tower and the width of the canal. Height of the tower and the width of the canal. It is on the bank of a canal, and on the other bank directly opposite to the okay. So from this figure, it's A, B, C, D, 60, 30, 20. So this is my question number 11. We directly draw the diagram. Triangular diagram. This will be 60 degree, and this will be 30 degree. So this is my 30 degree, sorry 60 degree. Here to this point is 60 degree, farther point is 30 degree, and this distance is given to be 20 meters, 90. This is A, B, C and D. This is already given. A, B, C, D, 60, 30, 20. Okay. What we need to find is, we need to find this. This is BC is nothing but which is the width of the canal, and the height of the tower. This height of the tower is AB. We need to find this. So how will you find this? Generally, this AB in triangle ABC and triangle ABD, the side common is AB. So I will write in terms of AB only. So first in triangle ABD, angle B is 90 degree, given 90 degree. Angle D is nothing but 30 degree, and DC is equal to 20 meters. So applying tan of 30 degree is nothing but AB by BD. So, but you also know this tan 30 degree is nothing but 1 by root 3. So which implies that AB equal to BD by root 3. This is my first equation. Relation of equation is the second thing. Now in triangle ABC, angle B is 90 degree, angle C is 60 degree, and nothing else is given. So applying tan of 60 degree, you want to be AB by BC, and you know that tan 60 degree nothing but root 3, which implies that AB equal to root 3 BC. So equation number 2. Now, equation number 2. Now, yeah, this is AB. Both are equation 1 and 2 will be equal because this all are AB. So this, that is from 1 and 2, this is BD by root 3 equal to root 3 BC, which implies that BD equals to 3 times of BC. I'll take it as this to be my third equation. BD equal to 3 BC. Now from the figure you can see that this see that this what is BD CD. So from the figure we take BD minus BC equal to DC. Okay, you said okay. So this substituting the value of BD here, so which implies that BD this is 3 BC minus BC equal to DC. From here, this implies that is 2 BC equal to DC, which implies that BC equal to DC by 2, nothing but 20 by 2, which is nothing but 10 meters. So BC is 10 meters. BC is 10 meters. So if you substitute the value of BC in equation number 2 here, so what this becomes that AB is equal to root 3 BC. It is going to just AB equal to root 3 BC, which implies that this AB equal to 10 root 3 meters. And I've substituted the value of BC. So 10 root 3 meter. Question what we need to find is this BC and height of tower. So height of tower is AB, which is 10 root 3 meters, and BC is the width of the canal, which is 10 meters. Is the answer. Now question number 12. The question number 12 says that from a top of a 7-meter high building, the angle of elevation of the top of a cable tower is 60 degree, and angle of depression to its foot is 45 degree. Determine the height of the tower. Okay, question number 12. This is question number 12. It says that from a building, and let's suppose this is my building, this is my tower. And this is suppose that this is parallel line, ground, and let's just suppose this is A, B, C, D, and E. 90 degree, also 90 degrees, complete 90 degree. It is given that this angle of elevation is given to be, this much angle is given to be, question number 12, it is given to be 60 degree and foot is 45 degree. 60 degree, and the angle of depression to the foot is 45 degree. This is 45 degree. Since this is 45 degree, this will also be 45 degree. And it is given that the height of the building is 7 meters. 7 meters. And what we need to find is this complete height. This complete height we need to find. But this DC, since I have done this parallel, so this DC will also be 7 meters. Now, how to solve this? So, in triangle ABC, angle B is 90 degree and AB is 7 meters. So, what is tan 45 degree? Tan 45 degree nothing but AB by BC, and AB is given to be 7 meters, BC you don't know, and tan 45 is 1. So I will substitute the value of here, so which implies that, sorry, which implies that this BC is equal to 7 meters. 7 meter. BC is 7 meter. Now BC equal to AD. Why? Because it's a side of a parallelogram. Side of a parallelogram. Now in triangle EDA, this angle D is 90 degree, and this AD you have now just calculated to be 7 meters, and angle A is 60 degree. So tan of 60 degree is nothing but EA by DA or AD. Now EA you don't know, and but AD is going to be 7 meters. Now tan of 60 degree you already know, this is nothing but root 3. Solving this is EA equals 7 root 3 meters. 7 root 3 meters. Now DC you already know, you have ED you have calculated. Sorry, this is not ED, this is E, not EA. This is ED, sorry, this is ED. ED you have calculated. So the height of the tower is tower equals to ED plus DC. Now ED you have calculated 7 root 3, that's going to be 7 meters, which implies 7 root 3 plus 1, 3 1 meters. This is the answer. This is the answer. Now next is question number 13. It says that as observed from the top of a 75-meter lighthouse from the sea level, the angle of depression of two ships are 1345 degree. If the one ship is exactly behind the other on the same side of the lighthouse, find the distance between the two ships. This is also simple. This is also simple. Question number, this is 15. So suppose this is my lighthouse. New every time presenting the C. There are two boards. Let us suppose the board size is of point size 1345. This is going to be my 45, and further this will be my 50 degree. Since the board is 45 degree, so you know that this angle, since angle of depression 45 degrees is 45 degree is greater than 35 degree, which implies that the board 45 degree depression is nearer. Now this you know that this angle is given to be 30 degrees, this is farther, and this is given to be 45 degree, this is nearer. So since this is 45 degree, this angle will also be 45 degree. And similarly for 30 degree, this angle will be 30 degree. This is 90 degree, and there are two ships. Let's suppose this is P, this is at point P and Q. This is, let's suppose this is R, this is SR is the lighthouse. This given that the lighthouse is of height 75 meters. So this is 75 meters. What you need to find is the distance between two ships. Between two ships will be P and Q. This I need to find. So applying the basics. So in triangle SRQ, angle R is 90 degree, angle P is 45 degree, and SR given to be 75 meters. So what is tan 45 degree? So tan 45 degree from the this in this triangle, tan 45 degree is SR by PR, which implies this SR is 75, PR is not going to be to find a PR equal to 1. What is 1? This value of tan 45 degree, which implies that PR is 75 meters. 75 meters. This you have calculated. Let's suppose this is my 1. Now in triangle SRQ, angle R is given to be 90 degree, SR is 75 meters, and angle Q is 30 degree. Now applying tan of 30 degree. So tan of 30 degree is nothing but from the triangles is SR by RQ. What is SR is going to be 75 meters, and RQ we don't know, so we will write RQ, and what is equal to this tan of 30 degrees is nothing but root 3, which implies that this is RQ. So now RQ is nothing but 75 root 3 meters. This is my second. Now you need to find QP. What is QP? From this graph, this is QP is nothing but this is QR. So this is QR minus PR. Q1 or this is RQ and Q are the same. So this is 75 root 3 minus 75 is nothing but 75 root 3 minus 1 meter. This is QP, which is your answer. This is distance between the two ships is 75 root 3 meter, which is the answer. This is the answer. Now next is, so this is question 13. Next is question 14. This is question number 13. Next is question number 14. Next question number 14 is question number 14. It says that a 1.2 meter tall girl spots a balloon moving with a wind in horizontal line at a height of 88.2 meter from the ground. Okay. The angle of elevation of the balloons from the eye of the girl at any distance is 60 degree. After some time, the angle of elevation reduces to 30 degree, which means that from 60 to 30, that is the balloon had moved far away. And find the distance traveled by the balloon during the interval. So I'm directly just this diagram is given, so I'm directly drawing the triangular diagram. This triangular diagram says that and this is the girl. This is, this is the ground, and it is given that the angle of elevation to here and angle from elevation from initially it was 60 degree and then it changes to 45 degree. So let me rename this triangle. This is A, this is B, C, D, E. What is given that the height of the girl is 1.5 1.2 meter. So this is 1.2 meter girl. The distance of balloon from the ground is 88.2 meters. So C, this is B dash, this is D dash, and this is C dash. So this will be 1.2 meters as it is, and this height is given to be 88.2 meters. What else is given? This is initially this angle was 60 degree, elevation given to 60 degree. Now it has changed to 30 degree. What we need to find is the distance traveled. That is this much distance. Either BD or BD dash are all the same. So this distance need to travel. This is need to find. So the angle is this angle is 90 degree. There is 90 degree. So from the diagram itself, you can see that DD dash is 1.2 meters and ED dash is 88.2 meters. So ED equals, what is ED equals? This is 88.2 meters minus 1.2 meter, nothing but 87 meters. ED is 87 meter. Now you can see from diagram that is ED equals AB equals ED equals 87 meters. So this AD AB equal to ED. Now in triangle ABC, and ABC, this angle B equals 90 degree, angle C equals 60 degree, and AB you calculate is at 87 meters. So which implies that which implies that if you take tan theta, this that is tan of 60 degree, nothing but AB by BC is perpendicular by base. AB is going to be 87, BC you don't know, but that value of tan 60 is nothing but root 3. So which implies that BC equals 87 by root 3 meters. So this 87 by this I take it as 1. Now in triangle EDC, angle D is 90 degree, angle C is 30 degree, and ED equals, we have calculated that this is 87 meters. So tan of 30 degree from the figure is this is ED by DC. Okay, ED is going to be 87 upon DC, and this value is equal to 1 by root 3 pi, because tan of 30 degrees is 1 by root 3. So you can see that this DC is nothing but 87 3 meters. And but what we need to find is that is BD. BD equals, from the given diagram, BD equals CD minus BC. So what is BD? BD CD. So with the CD from here, this is, you can put the value from here to here. The CD is nothing but 87 root 3. And what is BC? You can calculate from here. You already calculated. You can put the value from here is 87 by root 3. If you take the LCM, this is nothing but this is 87 into 3 minus 87 by whole root 3. Nothing but this is 87 into 2 by root 3 meters. Or you can simply write it as this is, which implies that this is, from there you can write that as VD, nothing but 87 into 2 by into root 3 by 3. It is root 3 into root 3, multiply and divide. So this 3 1 the 3, and this 3 to the 6, 27, 3 9, 27, equal to 58 root 3 meters. So the distance between the distance traveled by the balloon in the time interval is 58 root 3 meters, which is the answer. Till next is 15th question. A straight highway leads to a foot of a tower. A man standing at the top of the tower observes a car at an angle of depression of 30 degree. While it is approaching to the foot of the tower with a uniform speed, 6 seconds later, the angle of depression of car is found to be 60 degree. See, you can see that this angle is decreasing, which implies that the distance of car from the foot of the tower is decreasing. Angle is increasing, which implies that distance is decreasing. Find the time taken by the car to reach the foot of the tower from this point. So this is 15th. So 15th is simple. That is, this is tower. So first you observe that if you join this, next you join this. You observe that initially the angle was 60 degree. Initially the angle was 30 degree and then it changed to 60 degree. This was 30 degree and it later changed to 60 degree. In how many seconds? Time is given to be in 6 seconds, and it traveling with a uniform speed. This uniform speed is important because the speed here is constant. And 6 seconds later, so time is given to be 6 seconds. Now suppose this, I am marking this A, B, C, D. C and D as a two position of this car. D is the initial position of the car and C is the position after 6 seconds. Now it is to find that the time taken by car to reach the foot of the tower from this point. From point C, how much time it will take to travel to point B, that is the foot of the tower. And it is given that the height of tower and the speed is only given. Find the time taken. So only time you need to find. So in triangle, let the speed, I'm taking the, let the speed be v meter per second. V meter per second. The time is going to be second. I am assuming this is v meter per second. So in triangle A, B, C, Now you need to know that this time taken by to travel B to C is 6 seconds. So the distance will be distance, it is d equal to speed into time. This is speed into time, which is nothing but 6v meters. 6v meters. This is d distance. Let's suppose this is my d1. You need to find this distance d2. Now, what it is given that in triangle ABC for this AB is common to for both triangles, that is triangle ABC and triangle ACD. So, triangle ABC, tan of 60 degree is nothing but AB by BC. Now, tan of 60 degree, you already know this is nothing but root 3, which implies that BC equal to AB by root 3, or alternatively you can say that this AB is root 3 BC. Root 3 BC. Now, in triangle ABD, you can say that is tan of 60 tan of this is angle is, so this angle is given to be tan of 30 degree in nothing but AB by BD. Now what is tan 30 degrees? 1 by 3. From here you get that AB is BD by 3. Now from equation 1 and 2, I will suppose this is my equation 1 and equation 2. 1 and 2, AB is equal to AB, you already know, which implies that root 3 BC equal to BD by root 3, which implies that BD equals to 3BC. 3BC. Now, what is BD equal to 3BC? Now, BD equal to DC plus BC. Now, value of BD is given to be 3BC equal to DC plus BC, which implies that DC is equal to 2BC. Is equal to twice of BC. So, which implies that D2, this distance D2, which is BC, equal to D1 by 2. Now, D1 by 2. So, what is the time taken? So, time taken, let's just suppose time taken is T dash. Time taken is distance upon speed. Distance is going to be D1 by 2. Distance upon speed, and speed is V divided by V. From here, what to get that this T1 T dash equal to, this is D1. D1 is going to V. This is 6V. 6V by 2V. Nothing but 3 seconds. T dash is 3 seconds. To reach from C to B, it will take 6 seconds for the car. Which is the answer? Now, what is 16th? The angle of elevation of the top of a tower from the angle of elevation of the top of a tower from the 2 points at a distance of 4 meter and 9 meters from the base of the tower are in the same straight line with it are complementary. Okay, prove that the height of the tower is 6 meters. This complementary is going, this complementary to prove that this is. So this is another good question. So 16, this is the last question of the exercise in this chapter also. So it is given that this diagram is like this. Sorry. and this is given that this is, and what is given that this is 90 degree. This is the tower. From top of the from top 2 point at the distance of 4 meter and 9 meter. So this is my 4 meters. This is my 9 meters already given. This is A, this is B, C, this is D, and since I am taking this D to be theta, so this will mean 90 minus theta. Why? Because these are complementary angle. So in triangle ABC, what is tan of theta? Tan of theta is AB by BC, which is AB by BC is given to 4, and which implies that AB equal to 4 tan theta. 4 tan theta. Now, in triangle, suppose this is my 1. In triangle ABD, this is tan of 90 minus theta is given to tan theta. This is AB by BD, and which implies that this BD is given to be 9. So this is 9 and this is AB, which implies that AB equals cot, this is 9 cot theta. AB is 9 cot theta. So from 1 and 2, into AB is equal to AB, so 4 tan theta equals 9 cot theta. Now you know that what is cot theta is 1 by tan theta, so this will become 9 by tan theta into 4 tan theta, which implies that tan square theta equal to 9 by 4, like that tan theta equal to under root 9 by 4, which implies that since tan theta is acute angle, so this negative sign get neglected and this positive only remains. This is 3 by 2. 3 by 2. Now, if you substitute tan theta, value of tan theta in equation number 1, so what it becomes that this AB, what is become that is AB is equal to 4 tan theta, which implies that is 4 tan theta. So this becomes 4 into tan theta value is 3 by 2. This is 3 by 2. So this is nothing but 2 net 2 to the 4. This is 6 meter. So the height of the tower is 6 meter. What is given that this height of tower is 6 meter? You have to prove, and you already proved that this is a 6 meter. Hence proved. Now the exercise over. The summary is that the line of sight is drawn from the eye of an observer to the point of the in the object viewed by the observer. So directly you are seeing the object. This is your line of sight. What the angle of incidence is viewed in the form by the line of this formed by the line of sight with the horizontal line level. In case that is the case, this is the case where we need to look up at the object. Now the angle of depression is viewed. This is formed by the line of sight with the horizontal, but this is below horizontal level. Previous one was this is above horizontal level, and in this case, that is in case of angle of depression, we have to look lower to view the object. Second is the height or length of an object or distance between the two objects can be determined by using the help of Trignometry's ratio. This we have seen from our equations. So with this, I am done with this application of trigonometry. Thank you for watching my video. Please like and subscribe if you do so. Thank you.